on this table, we need to find the equation and go from there. So the first thing that I would do is I need to find my constant rate of change. So I'm going to label my x and my y. My x is my years and my y is my time in inches, and I need to find the constant rate of change. So from this one, from 0 to 2, I'm adding 2. From 2 to 4, I am adding 2. But from 4 to 10, it skips a little. It goes, we're adding 6. And from 10 to 16, we're also adding 6. And from 16 to 20, we're adding 4. So it's changing a little bit, but that's okay. We can still find our constant rate of change as long as this side is consistently changing with that. So on this side, we're adding 2. This one, we're also adding 2. This one, we are adding 6. We are adding 6. And over here, we are adding 4. So it's consistently changing. So you always want to put your change in y on top of our change in x. So going vertically, if I look, my y is 2 divided by my x, which is 2. 2 divided by 2 would give me 1. The next one, my y is 2, and my x is 2, and 2 divided by 2 would give me 1. My y divided by my x would give me 1. 6 divided by 6 would give me 1, and my y divided by my x, which would give me 1. So I know that my constant rate of change would be written as 1. Now I need to do it as my y per my x. So it would be 1 inch, which is my y, per year, which is my x. Now when I look at this, this is given to us by this table, but if we did not know that we were given these years, if we read this in a problem, 1 inch per year, we would write that as 1x. So basically, this is saying 1 inch each year. And when we first got this tree, it wasn't not necessarily at 0. In this one, when I got it, when I personally got this tree, it was already 8 inches tall. Whenever you see that x is 0, what you need to do is add on whatever y is. So I would say plus 8. And this is my equation right here. Now over here, if you look, it doesn't ever have the 1 in front of it. If you want to get rid of that one, you can. So it should be x plus 8. So we're looking, this is x minus 8. C is the one that says x plus 8. Now the way we would check this is we plug in one of these numbers. So let's choose 4. What is 4 plus 8? Well, it is 12. So we know that's correct. Let's choose 20. 20 plus 8 would give me 28. So I know that this one is correct. So all of these are correct, and this is the way we would check it. Now over here, I forgot, we need to change all of those 2's to be 1's. I forgot to change that. So basically, we know that every year it grows 1 inch, and we started with 8 inches. Now when we look, it says Jessica bought a tree that was 1 inch tall. Well, we can stop right there because how tall was the tree when we got it? It was already 8 inches. So this one says, Jessica bought a tree that was 8 inches tall and noticed it was growing 1 inch every year. Well, 1 inch every year is like saying 1x, and we know that we started with 8 inches. So that one looks pretty good for me. Let's read number C, or letter C. So it says, Jessica bought a tree that was 8 inches tall. Sounds good. Plus, grew 1 foot every month. The one thing that was wrong with this is feet and months. Do we have feet and months over here? No. So we know that C is incorrect and B is the correct answer. Now the last thing for us to do is for us to graph. So years, I think what we counted by were 2's. So I'm just counting by 2's, and I think it would be exact. Now I don't think we can count by 2's on the going up and down because we wouldn't be able to get to 28. So years is representing our x, and our y is represented by inches. And I think we went by 4, so we went 4, 8, 12, 16, 20, 24, 28, 32, and 36. And we can stop right there. So now what we're going to do is say, okay, in 0 years, how tall was this tree? Well, it was 8 inches tall. In 2 years, it was 10 inches tall. So we're going to put a point right in between 8 and 12. In 4 years, it was 12 inches tall. Now we're skipping ahead a lot, so we go all the way to 10. it was 18, which is right in between the, I think that's a 16 and the 20 now. Where am I? 10, it's 18, yeah. So right in between 16 and 20. Sorry, that looks not like a 10. All right, then in 16 years, it goes up to 24. And then in 20 years, it's all the way up to 28. So now what I would do is I would connect all these dots. It may not be a perfect line, but this is a linear line, and these were linear equations. So this would be our line.